Hello viewer. Welcome to my channel. In this video we will discuss the cybersecurity best practices followed to protect Kubernetes cluster. Let's first brief about what is meant by Kubernetes clusters. A Kubernetes cluster is a set of machines, referred to as nodes, that are used to run containerized applications orchestrated by Kubernetes, an open-source container orchestration platform. Here's a concise summary of the key components of a Kubernetes cluster. Master nodes, control plane components responsible for managing and controlling the cluster, including the API server, controller manager, scheduler, and ECT. Worker nodes, machines that run containerized applications orchestrated by Kubernetes, with components like kubelet and container runtime, example, Docker. ECT, a distributed key-value store used for storing configuration data and maintaining the desired state of the cluster. Kubelet, an agent on worker nodes responsible for managing containers and ensuring they are running as specified. Kuba proxy, network proxy on each node that maintains network rules and enables communication and load balancing between pods. Container runtime, software responsible for running and managing containers on each worker node, like Docker or containered. Pods, the smallest deployable units in Kubernetes, containing one or more containers with shared network and storage. Services, define sets of pods and provide network access and load balancing to them. Config maps and secrets, resources for managing configuration data and sensitive information. Namespaces, logical partitions that isolate resources and create distinct environments within the cluster. These components work together to provide a scalable and resilient platform for orchestrating containerized applications in Kubernetes clusters. Protecting Kubernetes clusters is essential to ensure the security of your containerized applications and sensitive data. Here are some best practices and security measures to help safeguard your Kubernetes clusters. Keep Kubernetes up to date. Regularly update Kubernetes to the latest stable version to ensure you have the latest security patches and updates. Role-based access control, RBAC. Implement RBAC to control who can access and perform actions within the cluster. Limit privileges based on job roles to minimize the attack surface. Network policies. Define network policies to restrict communication between pods. Only allow necessary traffic to flow and deny everything else. Secure API server. Use TLS to secure communication with the Kubernetes API server. Enable and configure audit logging to monitor API server activity. Implement authentication mechanisms, such as client certificates, OIDC, or webhook authentication. Use pod security policies, PSPs. Enforce security policies at the pod level to restrict the usage of privileged containers and other potentially dangerous configurations. Image security. Scan container images for vulnerabilities before deployment. Use a container registry with proper access controls and image signing. Secret management. Use Kubernetes secrets to manage sensitive information like API keys and passwords. Encrypt secrets at rest and transit. Network isolation. Isolate your Kubernetes cluster from untrusted networks. Implement network segmentation to separate critical components. Resource quotas and limits. Define resource quotas and limits for pods to prevent resource exhaustion and denial of service attacks. Pod security context. Set appropriate security context for pods to restrict their capabilities and access to the host system. Use service mesh. Implement a service mesh like Istio or Linkerd to enhance security by adding features like traffic encryption, access control, and monitoring. Runtime protection. Implement runtime security solutions to detect and mitigate threats within running containers, such as Falco or Sysdig Secure. Backups and disaster recovery. Regularly backup critical data and configurations. Test disaster recovery procedures to ensure you can restore your cluster in case of a breach or failure. Monitoring and logging. Set up monitoring and logging for your cluster to detect anomalies and security incidents promptly. Use tools like Prometheus, Grafana, and centralized logging solutions. Regular security audits. Conduct security audits and penetration testing to identify vulnerabilities and weaknesses in your cluster's security posture. Education and training. Educate your team about Kubernetes security best practices. Stay informed about the latest security threats and updates. Third-party security tools. Consider using third-party security tools and solutions that are purpose-built for Kubernetes security. Implement network policies. Define and enforce network policies to control traffic between pods, ensuring that only necessary communication is allowed. Continuous security testing. Integrate security testing into your CI/CD pipeline to catch vulnerabilities early in the development process. Limit third-party add-ons. Be cautious when installing third-party add-ons and only use trusted sources. Each additional component can introduce new security risks. Remember that Kubernetes security is an ongoing process. Regularly review and update your security measures to adapt to new threats and vulnerabilities. Additionally, consider the specific requirements and constraints of your application and organization when implementing security measures. Hope you enjoyed the learning contents of this video. Please subscribe my channel to motivate me to bring up more contents on information technology.